So here we have a limit problem, and it's just the limit of f over g. But as I look at this, at -1, and this should be f, and this should be g here. G isn't defined. The limit doesn't exist at -1. But we have to be careful because whenever we look at a limit, we must look at left and right. So we really need the limit as x approaches -1 from the minus side of f. What's that equal to? What's the limit as x approaches -1 from the positive side? This should have been over there. Let's clean that up. -1 on the positive side. And similarly, we're going to look for those same things for g. Limit x approaches -1 minus, limit x approaches -1 plus. So when we look at the f function, this is 0, and also we're 0 coming in from the right. And for the g function, we approach -1 on one side, and we approach 2 on the other side. So this limit is f on the left, so we're really looking at the limit as x approaches -1 minus, and when I look at f over g, I get 0 over -1, and that's equal to 0. And when I look at the limit as x approaches -1 on the positive side of f of x over g of x, now we're looking at 0 over 2, and that's also equal to 0. So even though it looked like this was a non-existent limit because of this jump discontinuity, when we look at from the left and from the right, each of these are 0, meaning 0 is my answer. Pretty sneaky. Just a reminder, we always have to check, does the limit on the left side of C equal the limit on the right side of C? This is really required to show a limit exists or does not exist.